We're going to work through some mechanical advantage calculations for a lever. And so again, let's first sketch out our system. Sketch out our lever system. We'll have a fulcrum. One side of it we will have the force of the effort, or the effort force. On the other side we will have the force of the resistance, or the resistance force. We will have a distance to the effort. We will have a distance to the resistance. And so we can go ahead and put in our values here. Let's make our effort force 16 pounds. We will make our resistance force 32 pounds. Our distance to the effort will be 5.5 inches. And our distance to the resistance will be 2.25 inches. All right, and so one thing that we have to remember is that there are two types of mechanical advantage. The first one, ideal mechanical advantage, deals with distances, because ideally this is how the system would work. And so ideal mechanical advantage is equal to the distance of the effort divided by the distance to the resistance. So the distance of the effort in this case is 5.5 inches divided by the distance to the resistance, 2.25 inches, and we get a mechanical advantage, an ideal mechanical advantage of 2.44. Now, one thing to remember is that since we're dividing inches by inches, mechanical advantage is a unitless number. All right? And so what we're basically saying is we are have an advantage of about 2.44. In an ideal world that's free from friction and things like that. Actual mechanical advantage now is abbreviated AMA. Actual mechanical advantage is equal to the force of the resistance divided by the force of the effort. So how much resistance is there and how much effort is there? And so if we actually went out and tested our system, what would the resistance force and the resistance effort be? So in this case, we have our numbers, 32 pounds divided by 16 pounds, and that gives us an actual mechanical advantage of 2. So then we can calculate the efficiency of our system. The percent efficiency is equal to actual mechanical advantage divided by ideal mechanical advantage. And so we're seeing how close we got to our ideal mechanical advantage. And then if we multiply that number by 100, we can get it in percent form. And so our actual mechanical advantage was 2. Our ideal mechanical advantage was 2.44. Divide those numbers and multiply by 100, and you get a mechanical advantage of about 82%, or an efficiency of about 82%. And so we know that our efficiency will never be 100% because what actually happens is always going to be less than what ideally could be calculated. And the reason is because actual mechanical advantage takes into account things like friction, and ideal mechanical advantage does not.